Our essential question for today's lesson is, what is the difference between discrete graphs and continuous graphs? And how do we graph equations? So let's start by discussing what a solution of an equation would be. So a solution of an equation in two variables would be an ordered pair, x, y, that produces a true statement when the values of x and y are substituted into the equation. So we're going to look at an example of this where you would be checking whether or not an ordered pair is a solution to an equation. So our first example is the ordered pair -2, 3, a solution of -x plus 2y equals 8. Okay, so we will start by plugging in the equation. Now what you have to be extra careful with is the negative here on the x is different than the negative here on the 2. So you have the negative that's part of the x, the equation. Then the x value itself is -2 plus 2 times 3 equals 8. And this is what we're checking. Does it equal 8? So you go through and simplify. So the double negatives here in front of the 2 make it a +2 plus 6 equals 8. And 2 plus 6 is 8. So yes, it does work. Okay, now this by itself does not answer your question. You have to actually answer in a sentence afterwards that yes, the ordered pair -2, 3 is a solution. Okay, so you got to make sure that you're telling me that this ordered pair, the one that you tried, the -2, 3, is a solution to the equation -x plus 2y equals 8. Again, yes by itself is not going to be enough. You need to say that your -2, 3 is a solution. Okay, next we'll look at the graph of an equation in two variables. So it's the set of points in a coordinate plane that represents all solutions of the equation. So we are going to take a look at the graph. So here we want to graph the equation 2x plus y equals 2. Now the difference between this example and the examples that you saw previously is that in the previous examples I gave you a domain to work with, a specific domain. In this case I don't. I want you to graph the entire line for the equation 2x plus y equals 2. So the first thing we want to do is solve for y. Rewrite the equation so that the y is by itself. So we have 2x plus y equals 2. We're going to minus the 2x on both sides so that the y is all by itself, -2x plus 2. So we solve for y. Next thing we want to do is make a table. So this is the same as what we did before. Now this time, because I did not give you a specified domain, you get to pick your domain. You should always pick negative numbers as well as positive numbers, and 0 is always a nice number to pick as well. So I'll do -2, -1, 0, 1, 2. So these are the common ones that we use. We are going to plug them into the equation, -2x plus 2, so that we can find the corresponding y for each of these x's. So y equals -2 times -2 plus 2. So as we simplify that, the -2 times -2 times -2 is +4 plus 2, which is 6. So that's the point, -2, 6. Next is the -1. So -2 times -1 plus 2. So that's 2 plus 2, which is 4. So my ordered pair is -1, 4. Next is the 0. -2 times 0 plus 2. So that would just be 2, 0, 2. Y equals -2 times 1 plus 2. -2 plus +2, which is 0. So that's 1, 0. And the last one, -2 times 2 plus 2. -4 plus 2. -2. So that point is 2, -2. So next we need to make our graph and plot our points. It helps to look at what your numbers are, the domain and the range. So my domain, I'm using the -2's to 2's. My range is a +6 to -2. So when I set up my X and Y axis, I want to make sure that it is set up in such a way that everything fits. Remember, you need to label everything accurately. So you've got arrows on the end of your axes. That's the X-axis. This is the Y-axis. Make sure you label them with the X and the Y. Then you need to scale. Minimum set of numbers would be middle and end. I always go every other number. So then 2, 4, 6, 8. And make sure you go all the way around. Okay, you have to do the positives and the negatives going in all directions, all 4 directions. All right, so and then we start plotting our points. So -2, 6. Remember the -2 is first, so you go to the left. Then the 6 is second, so then you go up to the 6. Next is -1, 4, 0, 2, 1, 0, and 2, -2. Now remember, I wanted the entire line graphed, not just the, there was no specified domain, so we want to graph the entire line. So then we go through and draw the line going through all those points, and that's the equation 2x plus y equals 2. Okay, which was the 4th step. Draw a line through the points. Since I did not give you a specified domain at the beginning, you would draw the line through all of your points. And the last thing was to label the line with the equation, okay, which I did after I drew in my line. So up at the top there, you'll see that I labeled the line with the equation. So now let's talk about the difference between the discrete and the continuous. So discrete has a graph that consists of isolated points. Okay, so you can see here that each of these points are just individual isolated points. There is no line on the graph. And the way we would know to do that is that we have a specified domain. Okay, there was a specific domain that was given to you at the very beginning for graphing. With continuous, it has a graph that's unbroken. So there is a line that's drawn through. Your domain here is continuous. That means it includes all the fractions and decimals in between all the integers. Okay, so it would consist of all real numbers. Another example of a continuous domain would be restricted, but it is still, it starts at the -1, in this case down here, and it would keep going unbroken from there on, including all the fractions and decimals in between. So that's another example of a continuous graph. So previous video gave us examples with discrete graphs. The one we just did was an example of a continuous graph. Again, the main difference is for the discrete, I will give you a specified domain, and with the continuous, you will not be given a specified domain, or you'll be given a domain that includes an infinite amount of values, such as x greater than or equal to -1. Let's take a look at one more example where the domain we're given is a restricted domain, but continuous, because it's less than or equal to 0. So we'll graph it, we'll identify the range, and so we're going to use this process. So these were the same steps that I had on the previous slide. Solve for y, make a table, make sure you take note of the domain, plot your points, draw a line, and write the equation on the line. So we will make a table first. Notice that I used numbers from 0 and only negative values, and that's because of my domain up here. Okay? It says that I can only use x's that are equal to 0 or less than 0, so I picked 0 to -5. So now we're going to plug them into our equation. So y equals 1/2 times 0 minus 1. So that would be -1. So my ordered pair is 0, -1. Next, 1/2 times -1 minus 1. So that would be -1.5. So -1, -1.5. Y equals 1.5 times -2 minus 1. That one would be -2. So -2, -2. Next, 1/2 times -4 minus 1. So half of -4 gives you a -2. -2 minus 1 would be -3. So -4, -3. And then 1/2 times -5 plus, minus 1 is, that'd be -2.5, -3.5. So -5, -3.5. So those are our ordered pairs. So then we want to graph those. Let's see, we go to -5. So remember, your x and y axis does not have to be in the middle of the graph. So I'm adjusting it so that my ordered pairs will all fit. Don't forget your labels. 2, 4, that's an example of a middle and end. 2, 4. Like I said, I like to go every other number, not just middle and end. Makes it a lot easier to graph your points later. And so now we will plot our ordered pairs. So we've got 0, -1, -1, -1.5, -2, -2, -4, -3, -5, -3.5. Now remember, we can only draw a line that starts at x equal to 0 and goes only through the points that are less than x equals 0. So that means our line is only going to go in one direction. Make sure you have the arrows on the end. This is a good example of why we need arrows. There are times when the graph does not continue on based on our domain, so you want to make sure that you include the arrow where it's appropriate. So that concludes video 16. Don't forget to go back and answer your essential question at the end of your lesson. So what is the difference between discrete graphs and continuous graphs? We talked about that. And how do we graph equations? Okay, so we had a list of steps that help us with graphing our equations, making sure that you have all the other details as part of your graph. I'll see you in class.